All right, Chapter 9. What we're doing in Chapter 9, the overall idea of Chapter 9 is learning how to work with polynomials. We're going to learn how to multiply and how to unmultiply, per se. And that's going to be called factoring. But we're going to work with polynomials and kind of manipulate them all throughout the chapter in terms of understanding what they are and how to solve them. So a couple terms here that I want to make sure that we're comfortable with as we start, so when I use them, you're not like, what the heck are you talking about, as we look here. A monomial. That's our first big idea. When you think of a unicycle, you easily think of something with one wheel. A bicycle has two wheels. Okay? What kind of words start with the word mono? What? Monotheistic. What does monotheistic mean? One God. Let's think of another word that starts with the word mono. Monopoly. What does monopoly mean? At the end of monopoly, what do you have? One winner. Who does what? Has control of all the property. What else? What does that mean? I thought monotheistic?
Oh, that's what she...
That's what Zach said. I thought it was different, okay? You ever heard monocular? Monogram? Okay, all of those have the idea of one. So when we're talking about a monomial, the back word is nomial. Nomial means term. And so a monomial has either a single number or a single variable or a combination of numbers and variables that are multiplied together. So down here I have some examples of monomials. 7c cubed, 6x squared y to the fourth, 9xy cubed, and 10. All of these are monomials. They are one term connected by multiplication. Now, next idea, the degree of a monomial. All right, the next idea is degree. All you do to find degree is you add up the exponents. If there's no exponent there, and it's just like a c or an x, we assume that exponent is 1. So for example, the degree of x squared is 2. The degree of x to the fifth is 5. The degree of y all by itself is 1. But if I combine these together and get the degree of xy, how many variables do I have? 2. So I add up my exponents, so it's 2. So the degree is you add up the exponents. And then we said the degree of x is 1 because it could be written as x to the first. Now, the degree of a constant, remember a constant means a number, is 0 because there's no variable. So let's look down here at these examples. 7c cubed. That's really c times c times c. How many variables are there? 3, so the degree is 3. 6x squared. That's really x, x, y, 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 y. So the degree is 6. Does that have any bearing on the fact that the front number is 6?
No.
No. Okay, it's 6 because 2 plus 4 is 6. I put the third one on here because this is what people often make a slip of, and they put the degree as 3. Why is it 4, Luke? You're right.
Because the x without an exponent is always 1.
Okay. So that one has a degree of 4. And then last but not least, I put the number 10 at the very end. Are there any variables there?
No. Yes. No.
There's no variables there. Is it still a monomial, though? Is it something, a number or a variable? So it's still a monomial. But what's the degree? 0. Okay? So you can have something with degree 0. So when we talk about find the degree of a certain piece or a certain monomial, it should be very simple to do. Okay? So off to the side here, let's make 2 examples. 4x to the fifth y. Write down the degree. Raise your hand if you think you have it. Ryan?
6.
Would you agree? Degree is 6. Okay, next one. 12x y to the 10th z to the 11th. Drew? Not 21?
No.
You're sure?
Yep.
Why?
Because x is 1.
Okay, this x is 1, so the degree is 22. How many got both right? All right, I think we're good. Let's move on. All right, other vocabulary. Polynomial. Poly means many. All right, many, more than one. So if they have a polynomial, we're talking about something that has many, many terms. Monomial is one term, binomial is two, think bicycle, bifocals, two. Trinomial is three. Who had a tricycle as a child? Give it up for tricycles. They don't do turns well though. Okay? Tricycles always seem to tip on turns. And then anything more than 3 terms is called a polynomial. Okay? So 4 or more terms. Now, just like we say a person's name, Justin Berg, we put the Justin first in because our first name comes first. Okay? When we're writing out a polynomial, we typically write it in what's called standard form. And know a standard form just means the biggest number with an exponent comes first. So if something has a degree 6, it comes before the degree of 5. And so on and so forth, all the way down to something with a degree 0. What can have a degree of 0?
Number.
A number. So like the 5 has a degree of 0. And then to tell about the degree of a polynomial, it's the degree of the largest one. For example, if I asked, who is the tallest student in the class? All right, Sydney, how tall are you?
5'10".
Anybody taller than 5'10"? A couple hands went up. Jalan, how tall are you? 6 feet. All right, Jalan, 6 feet. Anyone beat 6 feet? Sam, how tall are you?
7'9".
7'9". Potentially a new NBA career. So I would have to think that Sam at 7'9" is therefore the tallest person in the class. So if I said, what is the height of the tallest person in the class? I'm going to say 7'9". I'm not going to add up all your heights and get a cumulative, we're 70 feet tall. No, we're going to say the tallest person is 7'9". So when I say what's the degree of a polynomial, I just want the highest degree. I don't want you to add up all the different monomials. So degree of a polynomial, just the highest degree. So here we go. Down here at example 2, we're going to try to name the expression and then name it by degree. How many terms does this one have? 3. So that's called a trinomial. How many terms does B have? 1. What's a one-term thing called? Monomial. And how many terms does this back one have? I see 3 parts, but only 2 parts are connected with addition. That x squared and the y, isn't this all one term? So we really just have 2 terms. And what's a 2-term thing called? Binomial. Thanks, Ryan. Binomial. Now, don't flip over yet. We've got to finish these. I'm going to go in red above. 7x cubed. What's the degree of 7x cubed? 3. What's the degree of 4x squared? 2. And what's the degree of 5?
Yeah.
Okay. So what's the highest one of all those?
3.
So we say it's a trinomial and it has a degree, a 3rd degree. No, you need a pencil? All right, negative 20. What's my degree? 0. Good. X squared y. What's my degree? 3. 7. What's my degree? 0. So what's the highest degree of all of them? 3. So as you're classifying it, you're not going to add them together. That's going to be a little confusing when you start to get more complicated stuff. Remember on this first one, the degree is 3. It's not 5. Okay, it's just 3. All right, flip it over. It says, write each polynomial in standard form, then classify by degree and the number of terms. Okay, so Standard form. Remember, standard form means decreasing degree. Okay, so the degree is going down. So which of these three terms has the highest degree? 2x, 3x squared, or 1? What's the highest? Well, 3x squared has a degree of 2. What is the degree of 2x? Degree is 1. And the degree of the 1 is 0. So in correct form, that's decreasing degree. Let's look at B. What's the degree of the first part? 3. Degree of the 5? 0. So it's already in standard form. 2x minus 9. Degree of 2x is 1. Degree of 9 is 0. So that also is in standard form. X to the 12th degree is 12. 3x squared. 2. 8. 0. So that also is in standard form. Trying to look for one that's not. 4x squared y. What's the degree? 3. X to the 5th, y to the 2nd. 7. 3. 0. X. Now, a little tricky here. When you put that degree 7 in the front, what goes with it? A negative. So, negative 7x to the 5th, y squared. Then what? What 4x squared? Plus 4x squared y. Then what? Plus x plus 3. Now we're in standard form. All right, our next one. X squared, obviously it's just x squared. Going down. Degree of the first one is 6. Second one, 3. Third one, 2. So is that correct already? X to the 5th y, x cubed, x squared. What about the last one? Is that in correct form? What do you think?
Yeah.
Why no? Should the 8 come first? What's the degree of the 8x squared? 2. Degree of the 3x cubed? So is that in standard form? All right, so many of these work. And normally, you're going to see stuff in standard form. And I don't want you to get thrown by the fact that, oh, it's already in standard form. That's the natural way to write it. But I just want to show you some unique parts that are not.
So, like on our homework, can we just write our writing standard form?
Straight out of the book? Yeah. Okay, all right. Now, let's draw a line down. Come back here to the top. Now it says classify it by degree. All right. What's the degree of the first one? Hold it up with fingers right in front of you. Is it 2? Is it 3? Is it 4? Is it 5? Is it 0? Show me what your degree is. Try not to show someone else. Hold it right in front of your chest so no one else can see what your numbers are. Sydney, why 2?
Because 3x squared, that's the y squared.
Okay, I would agree. Going down from there. Next one. Show me on your chest. Is it 1? Is it 0? Is it 2? Is it 3? Show me what you think B is. What is the degree? Jalan? Why? Okay, so it's x to the second plus y to the first. Good. C. Someone different. What's the degree on C? How many variables are there? Abby? Okay. Why? Yeah, there's just one x. Good. D. Someone else. Drew? 12. Very good. 12. E. Going down to E. What's my degree, Luke? 7. Why?
Because 7x to the 5th y squared.
Okay. You add the exponents of the highest one. F? Kyle?
2.
Good. 2. G? Mr. Robbins?
6.
6. And H? Mr. Switek? 3. Now, I know this seems really straightforward, but I want you to understand the degree of a polynomial. Is that different than the degree of a monomial? Who can put it into words? How are they different? Josh? So the degree of a polynomial is the highest degree out of all of the terms that you have. So the degree of a monomial is the highest degree of any one? Okay, all right. So it's the highest degree of any one of the monomials. All right. Okay, go back to the top. Now let's classify it by the number of terms. How many terms does this have? Count them. 1, 2, 3. What's the special name for something with 3 terms? Trinomial. How many terms? 2 terms. Special name for something with 2 terms. Binomial. All right. Run down the line with your partner. Name all of them. The last 6. Go. By the number of terms. Write them out. I want you to learn how to write and spell these. I know it seems trivial, but I want to learn how to write and spell these. All right, Luke. Dunsel, go.
Trinomial. Oh, okay.
Try by, then what?
Binomial.
Binomial.
Trinomial.
Okay.
Polynomial.
Poly, if you had to define it,
More than 3.
more than 3. You can say more than 3 or you can say 4 or more, whichever you prefer. Go.
And monomial.
Go.
Trinomial. And polynomial.
All right, bonus question. In the box at the bottom, I would like you to write a binomial of degree 7. Please write a binomial of degree 7. See if you can do it. Write a binomial of degree 7. What am I going to write? How many answers might there be? A binomial of degree 7. See what we got. Yes, simple and clean. Yes. Creative and good. No, that's a binomial of degree 4. July, do you understand what I'm trying to do? That's a binomial, that's a trinomial of degree 10. 3 terms, degree 10. And it's a polynomial of degree 10. All I want is binomial, degree 7. Yes. Creative. Simple. Good. Is that a y to the 0? Then yes. If it was a y to the 0, I probably wouldn't write it. All right, so here's what you have to do. For a binomial of degree 2, how many terms do you have to have? 2 terms. Connected by either a plus or a minus. I'll choose minus just to be creative. One of the terms has to have what? 7 total Well, what's the degree come from? Variables, right? So, can I say x to the 7th? What else could I say? X to the 3rd and y to the 4th. I like that. X to the 3rd, y to the 4th. So does that have degree 7? Yeah, and then what does the other one need to have? Anything so long as it's less than 7. So could I have 100 a to the 6th? Would that be less than 7? Yeah. And that's a very unique one. Okay, John?
Why can't you have 3 and 4?
You do. The 3 plus the 4 represents the total number of variables that you would have. If I wrote this out, it would be x, 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 y, 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 y.
I wrote that yourself.
Well, I'm typically, what I said about yours, I think you had a y to the 0.
No, I had a different one. It was like that one. So wrong.
Oh, I'm sorry. Well, if it was like that, then that's correct. My apologies. Okay? All right, we good there on degree and polynomials and trinomials and binomials and all that kind of stuff? All right. Shift over to page 7. Let me show you how we use these. When we start to add and subtract things in monomials and binomials and polynomials, what we need to make sure we're doing is putting like things together. If I said all the dancers go over there and all the basketball players go over there, we count out the dancers, we count out the basketball players. Okay? And this group is a certain number, and this group is a certain number. I'm assuming most basketball players are not dancers or vice versa. I tried to pick two things that were fairly different. Here, as we work through this, we have to first group things that are alike. So, what I'm going to do is I'm going to group my x squareds. Then I'm going to group my x's. Then I'm going to group my numbers. And now I look at each of my groups and I say, okay, I want to combine each of my groups. How many total x squareds do I have? Yeah, question, Jelani.
Can you add the same like terms from different parentheses?
It's exactly what you, and that's what we're doing. We're just putting them together to make it visual a little bit easier. I have 4x squared and 3x squared. Combining them together, what do I get? 7x squared. Notice, the x squareds don't change. We're not multiplying. It's like saying 4 apples plus 3 apples, we still have apples. What's 6x minus 10x? Negative 4x. And then lastly, 9 plus 4 is 13. Reviewing, how many terms do we have? So what's that called? 3-term thing. It's called a what? Trinomial. What's the degree of my trinomial? 2. Because the highest one is 7x squared. So the degree is 2, and it's a trinomial. Now, this is the easy, straightforward ones with a plus. Okay? Let me introduce you to the ones that are a little bit more difficult, but really not that all difficult. See this minus right here? Whenever you see a minus in front of a parentheses, I want you to put a negative 1 there. And no, this goes back to 2 chapters ago when we were distributing negatives. That negative has to go to the first one, and to the second one, and to the third one. So before you do this problem and start combining things, we need to first, Justin, distribute. And so this is what it's going to look like. The first part doesn't change. The second part becomes negative 1x cubed, negative 7x, and positive 4. By the way, why is that a positive 4, not a negative 4? Yeah, it was negative, it becomes positive. All right, now that we've distributed and got rid of the parentheses, now we can group. Here's my cubes. 2x cubed minus 1x cubed. 5x squared. Negative 7x plus 3 plus 4. How many x cubes do I have? 2 of them minus 1 of them is 1x cubed. 5x squared, 7x plus 7. Let's classify this. What kind of omial is it? It's a polynomial. What is the degree of this polynomial? What do you think? 3. Very good. All right? Just trying to show you different patterns here. And down here at the bottom. Let's distribute. Negative 5x to the 4th plus x squared. Who can distribute the second part for me? Can you know? Take that negative 1 and multiply it to all 3. Careful, negative 1 times 8x squared? Good. Negative 8x squared and negative 1 times negative x? Positive x. Good. Now let's group. Negative 5x to the 4th minus x cubed plus x squared minus 8x squared plus 1x. What combines? Isn't it just these two? Anything else? So here's our answer. 5x to the 4th minus x cubed minus how many squares? 7x squared. If you're not sure about that, realize that's a 1x squared there. Plus x. Most people are not going to put 1x, we're just going to put x. What kind of nomial do we have? Polynomial. What's the degree? The degree is 4. All right? Now, a little trivia. What's 1 squared? Everybody say it out loud. 1 squared is? 2 squared is? 3 squared is? 9. 4 squared is? 5. 6. Don't look. 7. 8. 9.
81.
10. 11. 12. 13.
169.
Okay, so let's fill these in. 11 squared is 121. 12 squared is 144. Most elementary schools learn through 12s. 13 squared is 169. So, here's what I want you to do. Pencils at the ready. Pencils or pens? Either one. Draw a line through 13, underneath 13. Gotta get ready, Donna. This is a race. Can't start. I'll tell you in a sec. When I say go, as fast as you can, I want you to write the perfect squares down to 13. On your mark? And when you finish, stand up. Get set. Go. Don't look up. If you look up, you're disqualified. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, Ryan, go. What were they? You were first.
1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and 169.
All right. Over the course of this chapter, we're going to learn all of those.
They're all right there.
Yes, but that will disappear at some point. All right? But that's up there for reference. All right? So, over there on the side. All right. So our homework here, as we look at section 9.1, is just 1 through 33 odd on page 459.